I want to tell you about my little friend Pablo. Pablo is still swimming around at the top of the jar. But he's inside this goopy water and that is somewhat questionable whether Pablo will make it through the weekend. Do you think Pablo can make it through the weekend? I sure hope he does. I guess we'll find out, huh? Okay. Say goodbye to Pablo. Bye, Pablo. Pablo's a nice guy. Welcome back. Can't do the Spanish accent the whole time. Very sorry. 99. Almost to 100. Yeah, baby. Solving rational equations. I think you'll, I have no idea if you like this. I don't know if you like anything that I do, but if you're forced to watch it, then, just do what you're told. Yes, okay. Will we start over here, please? Yes. Let me give you a definition of a rational equation. A rational equation is an equation containing at least one rational expression. That means rational, again, means fractions. I've been drilling you on this math vocabulary business for like 100 lessons here now, just about. And it's got equal sign in it. Maybe it's going to have x, it's going to have some numbers, it might have a little bit of adding and subtracting in there, but basically we're writing stuff with fractions, and there's an equal sign. This over here is just an expression, and that over there is just an expression, but this right here, my friends, is a rational equation. And I want to show you two ways. Gotta be careful, I don't want to get two ways to solve these problems. The first examples that we have here on the board, we will be using cross products to solve. And then when we make it a little bit more complicated, we will use the least common denominators. But in all these, we want to watch out for S's, for ES's. Extraneous solutions. Extraneous solutions. Oh, I'm tired. Yes. All right. We will do that by always verifying. Tip number 2. Tip number 1. Always insert parentheses. Let's go. That's for you, Karen. All right. Crossed products. Let's insert some parentheses just for fun. Parentheses around everything. Yay! Cross product means we multiply these two together and we multiply these two together and put them on the same side. So watch this. We would have had 3 times x minus 6 is equal to 5 and x. Doesn't matter which order they're in, as long as these ones end up together and those ones end up together. That's how we're going to solve this rational equation. Unless you're really smart and you can figure out what these answers should be. 3x minus 18 then equals 5x. And we finish this off and solve it. Here we go. So x equals -9. But wait, I'm not done yet. I need to make sure that that jives with the original equation. We'll show you somewhere it's very, very important that we do that. So let's plug in a -9 where there were x's. Make sure that no laws of nature are broken. 3 over -9 is -1/3, and we're looking for that to equal what the other side is equal to. 5 over -15. Are those equivalent? Yes, they are. We can proceed, and we can use that answer. Congratulations! You just completed your first rational equation solving exercise. So long, pal. Okay, here we go. Let's take this one here and let's do the same exact routine. We're going to first, number 1, insert parentheses around all those suckers. And now we're going to cross multiply. You two, you're going to multiply by each other, and you two, you're going to play nicely. X times x minus 1, yay being equal to 4 times 3. Oh, this is a little more complicated. When we FOIL this sucker, we get x squared minus x is equal to 12. You smell that? I can put them all on the same side, and lo and behold, look what I've got. I've got myself a quadratic equation. Well, I can solve that, and you can too. So let's do that. And this is factorable, hopefully. And we got this equals 0 thing from our last episode. Yes, we do. So if we factor this bad boy, we've got a -4 and a +3. Yep. And using the 0 product property, we know that if x minus 4 equals 0, this equals 0. And we know that if x plus 3 equals 0, then this thing equals 0. So therefore, x is 4, or x is -3. But wait, we have to check. We go back to our original equation and make sure that 4 works. 4 over 4, does that equal 3 over 4 minus 1? Are those equivalent? Well, 4 over 4 is equal to 1, and 3 over 4 minus 1 is 3 over 3, and that's also equal to 1, so that one checks out. How about -3? Plug in a -3 over 4. Does that equal 3 over -3 minus 1? Well, in fact, it does. And so, yes. And that's a good answer, too. And you're wondering, why do I keep having to do this if it's right all the time? Because it's not right all the time. You just wait. There will be some ASSSs in here very soon. Of course, why would we say that if that wasn't the case? Okay? Man, get off it, would you please? Second method, least common denominator. Well, we have a slightly different looking thingamabobber here, and that is we got some math on one side and it equals something else. So instead of there being equals there, it's a something else over here. Now this is going to require us eliminating the fractions by multiplying the whole equation through by the least common denominator. Again, horrible way of naming that one, but we gather up all the denominators and we see that 2 and x are all the factors. So I'm going to do something a little weird here. I'm going to multiply the entire equation through by 2x. So that means 2x times 3 over x comes first. Shall I do this in steps? Maybe so. Maybe that would help you. 2x times 16 over 2x, and then equals 2x times 11. X cancels out here. We have 2 times 3, 6. Here, the 2x's cancel out, so that leaves us with 16. And over here, we got 2 times 11 times x, that's 22x. What's this equal? It equals 22. What's that equal? 22x. Finish it off. What do we get? X equals 1. Should we check it? Yes, we should, because the tip was always verify. So I'm going back to the original problem. I'm going to plug in, what if this is 1? Will that work? Does 3 plus 16 over 2, which is 8, equal 11? Yes, it does. Yes, it does. That one works as well. Well, how did we do that? We found the least common denominator, and we multiplied everything through by the least common denominator. Yay, good for us. We did it. Yay, teacher. Here's another one. Now, we always, really in these rational equations, the only thing that's going to really mess us up is what if the answer ends up being 1? This isn't going to work, right? Because 1 minus 1 is 0, and 3 over 0 is undefined. What if this is 0? Or this is 0? It makes these ones something over 0. So we got to watch out, right? I'm just going to start right now and say over here, if x equals 1 or x equals 0, we've got some type of problem, okay? I'm just starting off thinking about where this might lead us to. This one is kind of yucky because 2 and x minus 1. That's all of our LCD for this problem. It's that and that and that. Yes? Yes. It's all that stuff. So if we're going to do what we did before, I'm going to put it over here on this side and multiply it this way because I'm feeling a little sassy today. I'll just say 2x here. And let's multiply that by this first. You see that 2x's will cancel out. I'll have 5 times x minus 1. I'm going to multiply this by this. You see that the x's will cancel out, and I'll have minus 2 times x minus 1. And I'll have another 2 left over. And then over here we go this times this. You'll see that the x minus 1's will cancel out, and I'll have 3 times 2x. But I have no denominators. And doing the math then this way, 6x. And then I've got 2 times 2 is a 4. I'm just going to move that over here. And now I've got negative 4x plus 4 equals 5, x minus 5, and solve. We've got over here now, I could simplify this to 2x. And then I would move this 2x over here by subtracting 2x. Gives me 3x. I'm going to add 5 to both sides, and I get 9er. And then I'm going to finish it off, and I get that x equals 3. We avoided that situation. Boy, that was close. And then to verify, I'm going to go back to our original equation, and I'm going to see if 3 still works. Put a 3 here, put a 3 here. And we get 3 over 2 minus 2 over 3. Does that equal 5 over 6? Well, we'd have to fix these, wouldn't we? 3/3 and 2/2. That gives us 9/6 minus 4/6. Does that equal 5/6? Yes, it does. Yes, it does. Sorry for all this mess. Sorry for all this mess. Let me clear this up, and then we'll do one where we do have extraneous solutions. So I promise you, it's coming. Do the math hustle. Here we go. This kind of looks like the original ones we were playing with, where we're going to do some cross multiplication. But before we get started, what solutions will cause problems like divide by 0? Well, it's that kind of like excluded value problem. What could x be here to make this equal 0? We're going to look out for x being 2. We don't want it to be 2. Or over here, 2x minus 4, when is that equal to 0? When 2x equals 4. Or, again, when x equals 2, 2 times 2 minus 4. So 2 will be an answer that we can't use if that comes out. So just pay attention. So, first tip, add parentheses. Cross multiply. X minus 1 times 2x minus 4 is equal to x minus 2, x plus 9. I FOIL these sides, you get 2x squared minus 4x minus 2x plus 4. Does this equal x squared plus 9x minus 2x minus 18? We shall see. 2x squared minus 6x plus 4 equals x squared plus 7x plus 18. All right, let's start collecting evidence here. We're going to subtract x squared, so we got x squared. We're going to subtract 7x. It gives us negative 13x. We're going to add 18. Add 18, that leaves us with 0 on that side and 22 on this side. Can I factor this? Can we do it? Oh, we're running out of time. Are you kidding me? Can I finish? I can't finish this. 3-minute next video. Sorry.